Shall I share the screen now or you will share?
You can share the screen.
Screen share करूँ?
Oh yeah, we will do it. First slide we go through the slide now.
Yes.
Thank you for joining today for the third live interaction session in the Learning Actors course. This is the 12th week. I hope you learned something new in this course and you're able to apply what we learned in the tech data, any other domain data. Today with us, we have one of our TAs, Vishwas. And today we'll talk about some of the topics we discussed in the last 12 weeks, kind of revise them. Some of them are kind of include some mathematical concepts or solving some problem, which might be interesting also to look at again. Also, it will be important for the your exams. Since a lot of you are registered for the exams, these questions might help you to solve the exams better. So I'll go to the slides. Hope the slides are visible. So now, okay. Yeah. So let's go to the slides. Yeah. So as I mentioned, this is live interaction 3 and we'll be revising for the week 9 to 12. But what we do, we'll revise the topics which you covered from the first week to the whole course. Thank you. No, the first few slides, I think Vishwas.
Okay. Thank you, sir. Thank you, sir, for introducing me and giving this opportunity. So there will be two main focus of this session. First one is having important contents from week 9, 10, 11, and then looking at important points from all over the course. So we'll go one by one. We'll start with important topic, which is eye tracking and eye tracking data, how it helps in learning analytics research, how we use eye tracking data, how we collect. So all these type of contents are there in a course, and you have watched different LEDs with that about that topics, right? So I'll start with basic only. So our computer screen lies in which quadrant? If someone asks you in which quadrant the computer screen lies, so the answer is it is in the fourth quadrant. So at the left hand top corner, the corner of the graph or the x and y axis, the combination point, intersection point comes, and this is the origin of the screen. From that point, it starts calculating the x axis and y axis. So I'll show you the sample data. Now for next 2 minutes, you can skip the content which is there on the right side. So focus on the table. Currently, it contains 3 columns: timestamp, x coordinate, and y coordinate. So timestamp is series-wise timestamps. It is kind of a sequential data, we can say. So it gives a sequential information about the location at which the learner is looking at. So x coordinate and y coordinate gives you the location on the screen. So what is eye tracking? Now you can focus on the main concepts of the regarding the topic, which is attention insights, then cognitive engagement, and improving learning design. So eye tracking data can be used to investigate multiple constructs. So first construct can be attention insights. So eye tracking provides a detailed data on where learners focus their attention and revealing which element of the instructional material captures the interest or cause of distraction. So that can be one area. Another one is cognitive engagement. Engagement can be of multiple types, but cognitive engagement is one of the interest area in which learning analytics can be applied. So by analyzing eye movement patterns, educators can infer cognitive processes such as understanding, confusion, or the effectiveness of a content presentation, like that. So that is the second domain. And third one is improving learning design. So learning design is again a broad area. Learning design actually facilitates the learning experience to the learner. So the insights gained from eye tracking, means who's eye tracking? The learner's is eye tracking. So if any research study involves the data collection of a learner, and data is of eye tracking data, so data will look like a data given in the table on the left side, and the improvement of a learning design may contain multiple actions or multiple things. So it can be an improvement of a learning experience through their trajectory, or giving them multiple options at multiple times. So insight gained from eye tracking can inform the design of a learning material and environments, so helping to enhance engagement and optimize the information delivery for better learning outcomes. So
and a couple of questions which can I ask?
Yes.
Yeah, so you mentioned in the previous slide that computer comes in the fourth quadrant.
Yeah.
Can you explain what is X and Y with respect to that?
Yeah. So we'll go to previous slide. So here we can see that this is the origin. We can start counting X and Y coordinate from these starting points, like in this direction and in this direction. Actually, in next slide, we will see one example also regarding that. Thanks for asking this question. So this is eye tracking data, and we'll be focusing on this table. So eye tracking data analysis can be done to reveal multiple type of learning behaviors, but with the help of given construct. First construct is, or first parameter is fixation. Next one is saccades, and third one is a scan path. So there are two important parameters we are focusing. One is a fixation, and then next one is saccades. So what is fixation? Fixation is a point in a time. So the eyes remain relatively stationary, allowing for a visual processing of the information. For example, in this next slide, we can see, just a second. In this next slide, we can see, for example, this is one AOI. AOI means area of interest. For example, you have developed something and the learner is looking at this area. So the fixation is a parameter which relates to the time. So for how much time, for how much duration the learner was looking at that particular time. So for example, learner was looking on this AOI for 1 second or 2 seconds. So we can say that learner was fixated on this AOI for 2 seconds or 3 seconds. It is like that. So fixation is construct regarding a duration for which the learner was actually looking at constantly, or here it is shown as a stationary, we can say. Next construct is, or next parameter is saccades. So saccade, a rapid eye movement that shifts focus from one point to another, often occurring between fixation. Means what? So for example, this is AOI, this is AOI 1, and this is AOI 2, means area of interest 1 and area of interest 2. So saccade is a movement from area of interest 1 to 2. Saccade actually is a movement. It is not related to the time. It is related to the coordinates now. So fixation, in this case, we can say that learner was fixated from say these are the milliseconds, and for 0.1 millisecond at this coordinate, means x coordinate 0.2 and y coordinate 2.4, it was fixated at that point, and till 25 milliseconds the learner was on that first AOI only. Then when learner actually moved his or her attention from first AOI to next AOI, it was a timestamp captured by the system which is 0.25 milliseconds. So the next coordinate of second AOI can be 1.4, which is x coordinate, and next one is a 2.4 y coordinate. So the movement, the rapid movement of eyes captured on the screen by using particular gadget, for example eye tracker, 2B eye tracker or something like that. So that rapid movement is called as a saccade. Okay, so this is the data which shows the sequential rapid eye movements, saccades of that learner, and we can see the data. So why I am explaining this thing? Because this is very important term and you may see similar type of questions which are important for your assignments also. And if you do assignment properly, then you will learn this topic in a very better manner.
So like that.
Yeah.
So if you see, this is fixation, and this is another fixation point, fixation 1, fixation 2, the path between fixation saccades. For this example, we are given that just for the example, we never get values like these very less values. We get really good values, like pixel from the usually computer monitor nowadays is 1900 into like 1600 to 2000 pixels big length, So I think we get a better pixel. So it will be really high. But giving the idea, just show that give the idea shows that the y-axis is fixed and x-axis is moving. So it's like fixating, saccade happening, fixating multiple points. Then they're moving the axis to 1.3, so a bit above.
Yeah.
Then they are moving. It's just to show that reading happening.
Yeah.
Then goes to the previous point.
Yeah.
Reading happening. That's the idea of to show the example.
Yeah.
So this one green, the big circle indicates fixated for more time. Small fixation, fixation, and the scan path you would.
Yeah. So the scan path is this is a good example of a scan path again. So scan path gives you the total saccade sequences connected to each other, we can say. So scan path is again a scan path is a sequence and trajectory of eye movements that illustrate how person visually explores the visual scene or a stimulus. So you can actually skip some loaded words like a stimulus and all, and in a simple way you can directly think about a scan path. So it gives you a trajectory of a learner's overall visual behavior captured using eye tracking tool.
Yeah.
Okay, so that trajectory is actually a sequence of different eye movements, and which gives us good insight about a learner's behavior, about their whatever it is shown on the screen for that learner. Because a discrete action for one fixation or two fixations or 3 saccades, it will not give us very much detailed information about the learner, but the total trajectory, which is a scan path in our case, gives us the detailed learner's behavior. So we can see learner was traveling from here to there, then went here, then came here, like that. And in a scan path, so at different fixation point, they give numbers also and duration also. So it gives a lot of information about the learner, that how much time learner has spent on that particular fixation point, AOI we can say, and then saccades, and then scan path means it again one step ahead, it generates a meta level diagram which gives an abstracted view using eye gaze. Means eye gaze gives you information using a different colors. For example, green color represents the average or a small time spent on particular AOI, and red color gives you, yellow and red color gives you the more time spent on particular AI. So that eye gaze pattern is also important for this eye tracking. So we'll see. Regarding eye tracking data analysis, I would like to add one or two important point. So using eye tracking, which type of behavior we can investigate in learning analytics. So reading behavior of a learner, how the learner is reading. So next one is how they're solving a problem, but the problem solving involves first the content analysis, means which type of content they are going for the first. Means I'm not saying a whole problem solving, but for example, they are watching video first before going to the problem solving, and then going to the quiz area, then going to the comments area, then going to the help seeking, like that. So you can actually investigate that behavior also. So reading the content, surfing we can say, so that kind of behavior we can investigate. So that was regarding eye tracking data and data analysis in LA. Next point, which is a different concept than eye tracking, which is a new concept, which is different type of analytics. We can see here types or phases of learning analytics. This is important in learning analytics, and they are subsumed in one another. We can see the descriptive analytics is integral part of every type of learning analytics, then diagnostic, then predictive, and then prescriptive analytics. So uh, definitions of these four phases are again given in the uh, week wise content LEDs. You better visit those LEDs in detail and see different examples of prescriptive, descriptive, diagnostic, and predictive analytics. We'll see one type of analytics here, which is descriptive analytics. Descriptive analytics can be executed or implemented by using different types of visualization techniques like bars and charts and diagrams. So what type of different charts and diagrams are there? A bar chart is there, histogram, pie chart, a scatter plot, line graph, box plot, and different types of visualizing techniques are there, right? For now, I am skipping the definitions of it, but you can surely revisit those definitions. So you will get for which purpose, which type of visualizing technique is used or chart is used. They are not actually 100% or for each other. They have their uh, uh, strength in representing particular type of data. So for specific type of interpretation, we use or we select particular type of representation. So that is what is hidden in their definition. So you are expected to go through the definitions and see the example. For now, we'll see one example, which is a box plot. Okay, this is very important type of chart. When we use box plot, so here it is given. It shows the data distribution. So distribution is another keyword. Then including median, quartiles, and potential outliers in the data. So we'll see a box plot. Okay, so this is one of the representation of a box plot, and below the box plot you can see the bell curve. Okay, so all of us know that bell curve at the center, which contains a 50% of the samples. Okay, so box plot is actually containing a 50% of the samples of a data in between quartile 1 and quartile 3. So it is called as interquartile range, which is IQR.
Q2, right?
Yeah. So this is Q2, means this is first part is Q1, then second one is Q2, and third one is Q3.
I think
so
the number should be Q2, isn't it? I think this should be Q2.
So another representation could be, so this is Q1, this is Q2, this is Q3, and this is Q4. Okay. Then this representation is, this is Q1, this is Q3, and whatever is coming in between Q1 and Q3, they have actually aggregated in between these two blocks as a Q2. So it is like that. So they are containing 50% samples in Q2 and Q3. Here Q2 and Q3 is not written, but it is called as an interquartile range, which is IQR. So whatever it comes in IQR comes in between Q1 and Q3 always. So Q1 and Q3, the middle portion always contains the 50% sample. Okay, and approximately 25% samples comes in the Q1 and 25% comes in a Q3. So other dots you are actually seeing before and after Q1 and Q3, they are called as outliers. Outliers means they are extreme values in the data represented by using a box plot. Okay, and again that outliers also is the reason to make your data skewed in a different way. But here this is not our topic. So box plot is our topic, and these are the quartile ranges, and 50% samples lies in between these boxes, and remaining 50% are distributed 25% to the left and 25% to the right. Okay, so this is one type of descriptive analytics we use to visualize the data. Don't add anything?
No, I think it's good. I think, yeah. Check the box plot is to display the distribution. It displays a median, also mean. Since this is a bell curve, the mean and median are same. Sometimes the data is not distributed normally. Then you would see the median will be the center line. The mean will be X mark somewhere before or after the median. So that's how the rest of the data distribution. So we'll move on. I think I would like to quickly go through these few key analytical techniques. Um, I think we would have talked about the k-means clustering, and I want you to, when you're reading the k-means clustering, I want you all to check how this data, the new cluster is formed. For example, in the k-means clustering, if you would have remember that we have a lot of data points. We have a lot of data points. I just changed that color. We made a lot of data points, and um, we might find the centroid of these two clusters. How the centroid is computed? Centroid is basically the mean of the nearest points. So you have to add all the x values divided by number of values you added to then y values. So you have to find the mean of these existing points, find the centroid. Please, I want you to go and check how this is computed. This will be useful for your exam also. And I think we discussed about sequential pattern mining again in the live interaction one. And please go and check the live interaction one and look at the pattern mining. We had clearly the S frequency, that is S support. Instead of frequency, it is S support. Then we had a high frequency, then high frequency mean. So the high frequency is basically the count of number of times this particular pattern occurred. Yes, support says that how many students had this pattern. When we ask you to identify the high frequency mean, you have to find the number of times this pattern occurred. Count to divided by number of students it occurred, not the total number of students. This is a common mistake people do. The reason we do here is that we want to identify if we choose, say that yes, support is 80%. Within the 80% students, I don't care it's nine students got it or all the students got it. Within that, if the pattern occurred, how frequently it occurred. So please check that S frequency, S frequential pattern mining, go and check high frequency and how to compute high frequency. And the multivariate regression, we didn't talk really, in detail, but check that also is very important topic. Then another key topic is Spearman's correlation, where we use non-parametric methods, check the Spearman's correlation, Pearson's Pearson's correlation, and Spearman's both check it. And this, I wanted you to highlight these three topics are very key and important for you to recheck. And I want to spend some time on NLP because that would have happened in the last week. NLP is a very important area, and due to the recent advancement, I think it has changed a lot, which we discussed in the class. We were talking about NLP as a one, identifying the number of words occurred in the given text, bag of words approach. Those are the very traditional approach, like 10 years or 12 years before. Then we talked about simply word embedding, where each word is represented as a vector. Then currently it's due to the recent advancement in the last 2 years, is called GenAI. The way people look at NLP has been changed. The relationship between the words, everything is kind of changed. But still the underlying principle to compute the nearest word, underlying principle to compute the suitable, correcting the dictionary words or correcting the mistakes is same. So I would like you to check those clearly. I just give a couple of examples. A document vector is mathematical text document as a vector in I documentation. For example, in a very traditional approach, if I am giving the text, say I would like to drink coffee in the evening. So how many words in this? I would like to each and every word, unique word, counted the document vector length. So if I speak 5 words and Vishwa speaks another 5 words, and there are 5 other people speaking the word 5 sentences. If I combine everything, I would like to know what are the number of unique words we're speaking. That's the vector length of this whole document. So it's not the one person. Like I spoke 5 sentences, other person 5 sentences. Like then another 10 people spoke each 5 sentences. Suppose we have like 50 sentences. I would like to find the unique numbers of words and occurrence of it. It's basically a dictionary function in your programming. If you give these words, call a dict, it will create a proper dictionary function for each word, number of times it occurred, everything. That is called unique document vector. The length of document vector depends on the size of vocabulary is used. For example, someone used different words, so the document vector would increase. in a class of 50 students, when you are trying to give an essay competition or give an essay assignment, you want to correct them, the words will be almost similar because students learn from the class. If suppose if I'm choosing a 50 random samples, ask them to write an essay, the document vector length will be more because each one brings their own domain. The vocabulary they used is different. So that is what we mean. Depends on the size of vocabulary they used in the classroom. And the common methods to do this bag of words or TF-IDF. We didn't talk about TF-IDF, but you can check them. So I would like to give one example here. Consider following sentences. Sachin likes to play cricket. Agim likes to watch cricket matches. So number of document vector, number of word is that. This is Sachin. 1, 2, 3, 4, 5, 6. Likes is already okay. So 2K. 7. Cricket is already covered. So 8. There are 8 vectors. So if you look at the document vector, it will be like Sachin, comma likes, comma chew, comma cricket, comma Rahim, comma watch, comma matches. If needed, we could remove the stop words, 1, 2, 3, 4, 5. If you can need it, we can remove the stop words. We could make the lemma of like watch, match, all those things will be a single, but likes become a like that. But now, if I want the statement 1 to be the document vector, it will be like us 1, 2, 3, 4, 5 for the statement 1. Statement 1 is basically combination of 1, 2, 3, 4, 5 from the document vector. Statement 2 is a combination of 1, 2, 3, 4, 5. Okay, I think instead we can write in a different way. The statement 2 can be 6, comma, 2, comma, 2 is 3, a watch because 7, cricket is 5, and match is 8. You can also write like this. So now each, if I have created, if I have 50 sentences from 10 different participants, if I created a huge dictionary of the documented length, I can represent each vector by this kind of values. There's the other way, instead of this, the other way, I can write a statement. One can be, it's like, I give a 1, 1, 1. If the vector size is 8, 1, 2, 3, 4, 5, I put 0, 0, 0. This is the vector. This particular statement 1 contains words from 1, 2, 3, 4, 5. For 2, you could able to do it. For 2, the words 1 is not there, like is there, 2 is there, play is there, cricket is there, and the game is there, watch is there, and the thing. You see, the second vector is really a big, like a seven values. But in general, if we consider the 10, 50 sentences, we will have a vector of say 1,000 words. 1,000 words will come. So the vector size would be like 1,000 unique words. And each sentence may have like only 5 or 6 words or 10 words maximum, right? So in 1,000 words, only 10 words will appear one. Everything else 0. So that is a sparse vector. That is we call sparse vector. So this to solve the sparse vector problem, even if you give the sparse vector to a huge neural network, some of the neurons will fire, some don't fire, then they contribute from. So to solve that, there are a lot of approaches came up, like the indexing approach, the one which we did, like a 6 the index approach, different approach. So I want you to check those clearly. Given this, how to create the document vector, how to match this vector to this particular form is what I want you to do to check it for the exams. And that's exactly this bag of work. If you do the simple approach, Sachin likes to play cricket, we can play it as a 1 or 0 value. That's all it is. It is just explanation. So the minimum edit distance of the matches is another important thing. So there are three possible operations we can do: insertion, deletion, substitution. In our case, we consider all of them as a equal computational cost, which means insertion also takes 1, deletion takes 1, substitution takes 1. Sometimes substitution is actually 2 computation costs. Somebody give a weightage of 2, 1 and 1 and 2. So for example, in the watches and matches, for example, here, WATCH, the minimum edit distance for this has to be substitution, this to be addition, insertion. which means there are three minimum edit distance happen. So whenever you see the words given in the question and the four options, try to compute those insertion or deletion or match the substitution operations and trying to replace to it as the minimum value. That's how you find the minimum edit distance between the questions, between the words given. So this is still has been used. This is kind of common. Nowadays, it's not just one minimum edit distance, like based on only the two words, the relation between two words or different distance between these two. Instead, it is based on the context, where it appears in a big sentence, all those things coming into picture, but that's a bit complex. But this is the basic in that approach. So the another thing we talked about is the bigrams, n-grams. I think would have mentioned it. So if I have a word like Rajesh likes to watch baseball matches, so the unique values is Rajesh likes to watch baseballs. Like only there are 6 words. But I wanted to put the context. For example, how many in the whole given the lot of corpus of Google News, the Wikipedia, Stack Overflow, whatever the Reach, the Reddits, all those content. People generate a lot of content. I want to give all the content feed into a big, scrap everything, feed into database. I want to know how many times that word, what is the probability if I say the words likes, the next word should be to compared to likes watch. So that we have to start looking at. So I like to drink. How many times the probability of next word being the tea compared to the probability of next word being the coffee? So that depends on the data we are feeding it. In order to identify it, what we do bigrams. Like Rajesh likes to watch. We can create a combination of words. And we can say that if the probability of based on probability of two given the current word is likes. What is the probability of the next word? This is next word given the current word, the current word. I'm sorry, I'm just not able to write it clearly here. The current word that will identify. In this case, it's just only one because there's no other likes to escape here. Suppose in a sentences, like if you have multiple times the two occurs or likes occurs, so we can identify those. So please watch these things also. This is very important thing to understand bigram. But bigram is enough because as per the law, bigram is enough. The current word depends on the previous word. But sometimes it depends on the previous last 2 words, the last 4 words, last 5 words. It was trigram has been happened, n grams, the 4 gram or 5 grams is gram. I think when this bigram idea was started like 15 years ago, though they used the Google had a huge server, they were able to do the 4 gram values and all. But as per the law, it's just last word is enough to 90% accurately, you know, um, it's enough to identify the next word. But in the current advance, with the word embedding, and you don't need to worry about that way because it can even understand the context, semantic meaning. Then it can understand where to next word will be not just based on previous word, also the context information comes. That's why if you combine the previous one, that is minimum edit distance to identify the right word and the next word occurring, you'll be able to predict the next word more correctly. Suppose I'm typing, I likes to drink tea. The tea, if I put it T O instead of T, I put T O. The T O is a right word, but in the context, it is wrong. That will suggest you T there because of this particular diagram tells you if a right comes, T will be more possible thing. Although you put a right word, say 2W or 2, that would try to convey and do give a suggestion that T will be the right word instead of 2. That's how we have to combine and do it. And yes.
So there are few questions in the chat also, so I'll read it out. One learner is asking that is the minimum edit distance is the same as Levestein distance?
Yes, yes, yeah, that's same. I didn't want to use the Levestein distance to create a table and go. You can moving window one by one because that would confuse. But in general, it's considered it's um, insertion, substitution, and deletion. Equal values. Yeah.
Next question is from the same learner only. Are always the number of bigrams one less than the number of unigrams? So I'm not understanding the question itself actually.
Yeah, in a moving window, for example, if there are 6 words, Rajesh likes to watch cricket. If you have a moving window, like moving sliding, basically, not moving sliding, Rajesh likes to. There are 5 combinations possible. So it's yes. If you think about the 3 words, it will be 2 less than that. Yeah.
Oh, okay.
That is the idea. Yeah.
So before that, when we were explaining
But
the
I can add it. Sometimes what we do, we actually have a null value also in the end. So null Rajesh also possible, matches null also possible. So there was research conducted in that. How many times this become the end of the start of the word? But in our approach, let's use it as a equivalent.
So previously, when we were explaining the eye tracking data and analytics regarding that, so one learner Marina asked, what type of devices are best used to capture this eye tracking? So as I mentioned that there are different types of eye tracker. Different companies also manufacture eye trackers. For example, Tobii.
People code.
And there are some free eye tracking gadgets are also there and websites are also there which are called as a web based eye trackers. So the accuracy of those eye trackers are not very much, but I think to conduct initial level of research, those web based eye tracker will give you a sufficient amount of data which are actually free in nature. Using a webcam only, you can use those webcam as an eye tracker, configure it, and there are specifically designed website to use those webcam as eye tracker, so you can conduct that. I hope the question of Marina is addressed.
So the basically for tracking web gaze tracker called eye gaze. Web gaze is the the library. You can go to web gazer and they have API written and it can be calling any website you are using it. And the best one is of course the best one will be like 1,000 hertz frequency one where you have to hold your head and do research. That is what people do in the reading research. But what we use in our lab is the Tobii Pro Nano. It's not really costly. It's you can buy 1 or 2 for the if you have research funds, and you can be attached to the laptop, and it detects really up to 60 hertz or no more than that 90 hertz if you have software. It's really good. Or there's some other company called People Core. They are coming with the wearable eye trackers. You can wear the couple of views. It's also easy. So yeah. I'll go to the next one. So another stats we talked about is the Kappa score. I think Kappa score is very important. We talked about 2 things there. One is the estimated accuracy and actual accuracy. What really happens is Kappa score. If you talk about Kappa score, there are 2 graders like me and Vishwas are standing here. Suppose consider we have like say 50 students are sitting in front of us. We both wanted to code whether the student is engaged or not. So consider me, I'm kind of biased. Whenever a student is not looking at the board, not looking at the notebook, when a student looks away or looks above, I might mark it as a not engaged. Being a learning scientist, for the Vishwas, Vishwas works on a qualitative analysis. Vishwas says, no, sir, like basically looking at a note, maybe looking at above, thinking, also engaged with the content, but not with the notebook. So engagement is not only with the interaction material. Engagement can happen also with the peers. Engagement can happen with the other materials, other interaction. Interaction can happen here. So suppose I'm coding as a researcher, I code everything as a non-engagement. That will lead to a research outcome. That will lead to a wrong answer. Vishwas would say code most of them as mostly engaged. That will also lead to the wrong outcome. But suppose if this is my research, I'm doing it in basically engagement. If I collect data, I'll completely biased. When I make inferences, it is based on my bias. It's not valid. To avoid it, we always have another reactor to check it's not biased, and we have opposite view. And we discuss it, and try to come up with a rubric or the code book. Then we both code them, and we check whether we both agree on the labels we did, engaged or not engaged. To do that, we check the Kogan's Kappa. This is how the Kappa has been used in the interrelated reliability in the education concept. This is kind of used from the humanities to education context. So that kind of avoids, bias between these two. Then this statement, if you both have interrelated reliability really high, that is, when we measure the interrelated reliability IRR, the Coben kappa should be equal to or greater than 0.8. When you write a paper saying that I wanted to understand the interrelativity, that you have to mention this data has been 10% of data has been measured with another researcher. Then we established a 0.8 kappa. Then half of the data I coded, half the data Shaw's code. With combined together, this data offers some value. Inferences made by the value is valid and that can contribute to the research community. Some others can take it for enhance it. But we took this IRR concept to the ML. Instead of comparing the two latest, we compared the actual value versus the predicted value. If you would have seen in the y predict in the linear regression, I can take any other formula, linear regression or logic regression. It's a intercept or C plus M into xi. The M is the weight we compute. Suppose if I have y is equal to 60 plus 0.3 xi means yi, which means I have to take the each given xi value, I have to compute. This is the predicted value, but we might have in our table what is the actual value also. This is the actual, y actual, this is the given value. Then we will find the predicted value. So after computing the linear regression formula, we have actual value, also predicted value. We like to compare both of them and we try to do it. Instead of the linear regression, we compare by using the mean square. What is the distance between these two values difference? Then we square them and we just found the mean of them. Then mean square tells you. Suppose in the logistic regression, if the y predict and the y actual, it's in the form of 1 or 0, the binary. Then we use the confusion matrix. We compute the confusion matrix. Then we apply the Kapa score. So the Kapa score idea is complementary to education for the inter-rater agreement. Then we borrow it in the ML to check whether the system is performing better. Why we use Kapa score? When the data is imbalanced. If the data is equally balanced, then we don't need to use Kappa. We can use accuracy, pressure, and recall. That is far enough. Data is imbalanced, then Kappa score comes into picture. When then another big example is that suppose in my class I have 1,000 students. Say I'm using 101 course. I want to measure the students who are not going to get 90% mark. We're not going to get 90. Okay. So out of 1,000 students, may 20 students get more than 90 mark. So my confusion matrix would look like 1, 0, 1, 0. The students who got more than 90 are 1. The students who got less than 90 are 0. So if I predict, this is my predicted value. This is my predicted value. This is actual value. If you look at it, what I did, my system simply said that every student will get less than 20 marks. To compute the accuracy, it is 98% accuracy because I was able to compute everything. Right? It's like everything, every student were going to less mark. But if I compute accuracy, 0 plus 980 divided by 1,000, I will get 98% accuracy. But this is actually wrong. The system is not doing anything. So kappa will be 0 here, which means kappa is applying no whatsoever, no knowledge on it. It's just simply randomly classified into one classes. So kappa equal to 0. That is possible the kappa get a negative also. It is worse than the negative agreement. Kappa above 0.0 is important. So what is this range of the kappa in education? I would say 0.4 in education is meaningful. But if you are doing kappa for the human raters to compare, 0.8 is the meaningful value. So please remember this. This is very key. And also go and check how to compute kappa, precision recall. Revisit those examples. That's very important. And the another thing is, yeah, there are three types of clustering. We talked about it. I think we mostly about two things like claimants clustering and hierarchical clustering. Please check the claimants clustering, how you find out the center of the clusters at the iteration. And also check the hierarchical clustering, that is Agnes or Diana, that is the agglomerate clustering. If I given a clustering like kind of consider the given a clusters, then um, then if I do here, then I do multiple clusters. Suppose if I have the clusters like 1, 2, 3, if I have a clustering, the cutoff is say this level. The number of clusters I have is only two. This is the one cluster. This is another cluster. If I have cutoff here, number of clusters I have 1, 2, 3, 4, 5 clusters. So understand that what is the meaning of when to cut off. So in the analytic clustering, each and every point will become a cluster in the end. But you don't want all the clusters. When to cut all those things? It depends on the your research question. Also, it is visible. It's actually evident from the figure. It says it has the distance between the clusters. Everything comes up. But when I say if I have a cutoff value at this range, how many clusters will come? You need to say how many clusters will form from this line. That the above one, like two clusters will be formed. So that's please read them again. That's all ideas. And yeah, so if in a given example of linear regression, consider we are given a formula for the model, trained model. So we get historical data and we go the formula tree. And we would ask you to given a new value of x values, would you compute the predicted values? So you should be able to compute them. Given a table, would you able to compute the value like uh, you've given a particular model, you compute the predicted value, also the actual value, then compare them and try to find out the mean square error. Those things I want you guys to check. Then quickly we go to the questions from the Google form. Um, okay. Will there be any assistance from your department? Okay. I think there's no one answer for this. Um, as a department, we are uh, already bandwidth is full, but depends on the requirement. If not us, there will be some student will be able to come back and assist them, and it depends on the request, case by case. So yeah, we actually wanted to help everyone in the country, especially the teachers, try using edtech learning analytics in the learning, so that to improve the teaching learning process better. So we're happy to do it, but I would not able to agree completely, say yes or no. But it depends on the request. We definitely help it. If you use a learning intervention with LA while doing a study for research purpose, how many samples? Um, it depends on the RQ. Suppose if you are collecting, say, even 20 students, if you're collecting the interaction scan part, like the interaction data, log data, if they interact with the 2 hours, you are able to capture 200 300 interactions per session of the student. It would go up to 4,000 or 5,000 data. That is far much enough to establish the claims like are they engaged or not engaged, are they taking the right path whenever given a prompt, are they changing those learning path or not. But it may not be enough to train the big model. Like I want to detect the affective states from this. It's not going to be enough. So again, it depends on the argues. So I would say the number of sample is not the number of interaction data you collate, and you want to compare them across two students. For example, if I try to collect data of 30 students, and I want to group them based on the self-efficacy. So consider I gave the self-efficacy test or the performance high versus low. So I split them into two groups. Consider so best cases we have equally half of group high versus low, and I want to understand number of times each group did a particular task, say reading and watching quiz or something like that, reading and doing quiz. If you want to compare, it's only 15 samples I'm comparing. That is not enough to prove any hypothesis. In that case, we need say 60 or 80 students to split and compare. So that's what I'm saying. If you want to compare iOS law or the based on some efficacy or the mindset or something, you need a more samples to collect data and compare. If you are collecting data to establish the learning path in general, the students who are going to the read, how many students would do after reading, do the quiz, or to understand which particular content is important. So 20 samples also with, sufficient amount of time they're spending. Say 4,000 or 5,000 log interaction data is enough to do that. So this is not direct answer. Depends on the arc. If you're comparing student-wise, go for more. If you're not comparing student-wise, you're going to and explore more data within the log data to establish a patterns and everything. Even less students with more number of intervention is enough. How can we extract analytics for extreme data or any other data which you have? Analytics. How can we extract data analytics for extreme data or any LMS data? Which you have? I'm not
data
sure.
from Moodle.
For Moodle, you could easily extract the data because Moodle gives you the current Moodle is really advanced, and we just have to go activity log. We can download the data. The data is really good. It tells you when the student logged in, what are the pages he was doing. The only problem in Moodle is that if say the system, suppose student clicks on the PDF in the Google Drive, we won't be able to identify what the student did. But now with current Moodle, which H5P, Moodle is able to give you to say upload a videos with in video questions. You can have a lot of different types of MCQs and everything is possible. If you install Moodle in your own system, it's very easy to collect the clickstream data. There's no need to create any other new approach for that. Like Moodle with your own server, very good like clickstream LMS. Virtual lab, yeah, that's a very key thing. As of now, there's no software to collect the users' clickstream data in virtual lab. People have used this for a lot in the media and the games, not in the education. So one of our students, I think is not part of this course here, but yeah, Anthony, you can check one of our students, Anthony, developed a software to collect the environment. And yes, published a couple of papers with ICC and IEEE conferences. And I think we're happy to talk if you have any virtual VR content, not virtual lab, VR content, it's a virtual reality content. Virtual lab, again, if it is virtual lab is website based, of course, the clickstream data would automatically help. Would neuroscience data capture be a good indicator of cognition potential? Okay, this is not actually going to be in this LA course. We also collect data. When I say multimodality, we just talked about facial expressions. We talked about eye tracking. We talked about log data. Also, content they use at the same time. That we stopped there because we are not able to cover more the tool-based course. Even this is too much. So we kind of covering the initial intro level. We wanted you to go and explore. But there are other census data can be collected in LA. Other data, GSR, yeah, EEG, the with the for that procytocros, GSR, EDA they collected. So these are sensor data has been collected. For example, new health data like EEG is a good indicator of a cognition load, cognitive load. GSR GSR EDA will tell you the attention a student is going on, cognition. So yes, this is kind of happening now. A lot of research is happening even in our department. A couple of students are working on this kind of data, and these devices are getting cheaper and cheaper, which means we could we could buy tens of them and go to school and start collecting data. So yeah, it's possible. And yeah, let's say some questions from the live interaction.
Yeah, from forum there is no question.
Any question?
I think we addressed those.
Okay, always the number 5 comes yes, I think. From the web page pictures, can we conclude the top left part of is not attracted from
Yeah, in the eye tracking thing, no?
In the Oracle eye
tracking. Yeah. So top left is we can say that that part was that AOI was not very
the student does not really look
attention was not there, visual attention was not there of that learner in the left area.
Yeah, that could conclude.
Yeah.
See what we do in a research. For example, suppose I'm designing a software, I would keep my time here. Okay, I think we have to open in some other way.
Yeah. Full screen.
I think we'll just do this screen. So what we do, we keep the timer here. Okay. How many times a student went on the time? For example, I'm giving a time task. Your children have to solve the problem in 30, 60 seconds, 60 minutes. How many times students go and solve the problem in time task? It's fine. I think we'll do it here. Thank you. So suppose I have the agent here. Suppose I have the learning content here, that the index of a content. And I have a text and I might have images. So I create AOIs based on this. This is AOIN based on how many times the student looking at the agent. If the agent has a different features, if the student is more looking at it, or more is asking the questions, or the agent is looking at the index part. So that what we call as the area of interest. So a lot of area of interest can be created within the system. Then we could analyze them in the after taking it up. Your question is right. From this particular data, we could conclude that the student has not visited it. So the best way is the heat map. I think heat map which I think we have shown the heat map in the class.
Yeah.
That best way is that heat map. The more focus they do, red color it indicates. Look at the heat map. And heat map is the best way to identify which part of the static image a student looked at it. In our case, we don't have a static image always. The agent is fixed, the index is fixed, the timer is fixed, the content changes. So we have a different AOIs, then we try to capture them and try to see whether the student is reading, how much is interacting with it. Yeah, I think I hope you answered all the questions.
Yeah, almost.
Thank you. Thanks for taking this course, and I hope you really enjoyed. And all the best for the exams.
Yeah.
And please apply this knowledge in your domain and your field also. Thank you.
One or two instructions only. So whatever the assignment questions are there, they are really important for the final exam. Final exam may contain similar type of questions, but you need to practice assignment questions in a rigorous way. Second thing, whatever we have covered today in this session is super important for the exam also. You should revisit this contents again and again, and also who have missed these kind of this particular session, also circulate it in your friends who have enrolled for this course, that revisit this session and have some group learning or something like that and solve those problems. So it will be helpful for your final exam. So that's all.
Thank you.